To better understand how JavaScript primitives work, let us first draw a distinction between statically typed and dynamically typed languages. In statically typed languages like C++, for example, when you define variables, you have to provide its type within the special keyword for that type. For example, to create a type integer, you use a special keyword int, and then you create a name for that variable, and the actual value has to match the integer keyword. For example, if you try to redefine this variable as a string, you're going to get a type error. It's just simply not going to work. In the same way here, if you use the int keyword and you create a variable, let's say b, but you assign it a floating point number, then you're also going to get a type error because the type of a keyword you use here to specify a value must match that value when you actually provide it. So for example, if you want to use a floating point number, there's a special keyword float, and you can name that variable, let's say f, and provide a floating point number. In this case, there's no error and everything is just working as expected. In the same way, in C++, you can create a character, and in order to do that, you use a single quote, provide the character, close the single quote, and there you go. You have a single character stored in a variable C. You can also create strings using a pointer, and you're simply going to create a string stored in this variable name. For Boolean values, C++ has a special keyword bool. Again, you can use a true or false value here, but the key thing to remember here is that the bool must actually match the value that you provide. If you put 1 in here, you're going to get a type error again. So this is statically typed languages where the type has a special keyword and it has to match the value. Now, JavaScript is a dynamically typed language. So what that means is that the idea of types here is completely irrelevant. And instead of having int, float, and bool and all these different keywords for a specific type of a value, in JavaScript you only have let, var, and const. And these keywords have nothing to do with the value itself. They only specify how that variable is going to be used in your code. But JavaScript is not entirely typeless language. There really aren't any coding languages out there that are entirely typeless because we have all these different values, for example, 1 and string. So we still have types. The only difference is that the type is only in the value. It's not really specified beforehand by any special keywords like in C++. And for that reason, so if you define a variable called s and you assign it a string value, it will automatically become string, hence dynamic typing. And later, if you redefine that same variable to some other type, it's perfectly normal for that value to simply change its type. Again, if you do it in a statically typed language, you'll generate a type error. And so here, for example, simply by specifying the value of type boolean, this variable becomes a boolean. Specifying keyword null will automatically make that variable of type null. If you use an object literal, the variable will automatically become of type object. And if you use a new operator, it's going to be an object because it's going to refer to the value of this instantiated variable. In the same way, if you use a function, in this case it's an arrow function, your variable will automatically become a function type. I'm not saying that a function is a primitive type. There are only 7 primitive types, and we're going to take a look at them in the next section of this tutorial. If you start exploring JavaScript primitive types individually, you might run into problems later. So what I decided to do is to take one of the JavaScript primitive types called number and explain the anatomy of JavaScript primitive types as a whole. The constructor function for the number primitive type is simply called number. In order to identify types in JavaScript, we use a type of function. It's a built-in function and it takes a value. You can pretty much just type anything in it. For example, an object, a primitive type, and we'll simply output the type of that object or primitive. So if you put the constructor function for the number primitive into the type of function, the result will be function because that's what constructor functions are in JavaScript. They are functions. But primitives also have literal values. So in this case, a number like 1, for example, would be its literal value. If you put 1 into the type of function, we no longer get the function, but rather we get the actual literal name of that primitive, which is number. For strings, it would be a string, and for booleans, it would be boolean. And in the same way, if you define a variable a and assign the value 1 to it, and then you try to run the type of function on that variable name, in the same way you'll get the literal type of that primitive, which is number in this case. But remember, number is an actual constructor, so we can use it with the new keyword to instantiate an object and store it in a variable. In this case, it's b, for example. And so when you do that and use the constructor to provide the value, and then you run the typeof function on that variable, you will no longer get number, you will get object, because that's what the new operator does. It converts your constructor function into an object. So this becomes an instance of that object. And obviously it's going to be of type object. And so that might be confusing sometimes, because if we created a number using the number constructor, how do you identify whether it's actually a number? Because remember, in JavaScript, we have all these different types of primitives. So it could have been a string, it could have been a boolean, but thankfully, all objects in JavaScript have a valueOf function attached to the instance of that object. One of the things you can do is you can assign the result of the function valueOf on that object to a variable, let's say v. And so what you can do after that is simply pass v into the typeof function at this point, and it will return the number. If you instantiated this with a string, for example, something like this, and you did this valueOf on this type of object, the type of v would have returned string. So basically that's how you identify types of objects that were instantiated using the constructor for that particular primitive. But whenever the new is used, the actual variable will carry a reference to the object rather than a specific primitive type. And so you just use the valueOf function to determine that type. This will work on all primitives, and in the next section we'll actually dive into the source code to take a look how that actually works. So we got all this theory out of the way, but how do you actually use primitives in a JavaScript application? Let's define our first variable and call it a. So in this case, the console will output undefined because we did not provide any value. It's exactly the same as saying something like this. There's absolutely no difference here. Remember that JavaScript is a dynamically typed language, so you can redefine this variable type from undefined type into anything you want. Let's use the typeof function this time to determine its type. You'll see here it's going to be a string. Just a small detail, the typeof function returns the name of the primitive in a string format. Let's see what happens if we take advantage of dynamically typed nature of JavaScript and redefine the value of this declared variable to something like a number. And again, we're going to use the same console function here to output the result once again. You'll see that the type of the variable changed to 75, and instead of a string, now we have a number. So the type has changed when we simply changed its value, and there are no type errors generated. Let's try the same thing with a boolean, and let's say do something like this. Running the typeof function on a boolean will return boolean. And by the way, you can do the same here, and it's going to be undefined. Previously, we just outputted the actual value, but if you run typeof on undefined, there's not going to be any difference. It's actually going to return a string, and as you saw in the console, undefined became a value in string format, whereas before, if you simply output, you see how it's actually less dark, so that means it's outputting the actual object, but when you do the typeof, it will output the string, not the object. You can also do the same thing for null value. And if you output that into the console, you will see it's an object because null is actually an object. But remember, there isn't a null constructor, so something like this is simply not going to work. It just doesn't exist in JavaScript. And finally, if you want to redefine the value of a to, let's say, some object, and you will output this into the console, just like any other example. And at this point, it will also be an object. So this is an object literal. And finally, the last type of a primitive in JavaScript that was added in ECMAScript 6 is the symbol. And it's created using, actually you don't have to use the new keyword on the symbol because it's a factory function. We'll take a look at factory functions later in my tutorials. But for now, if you output this, guess what's going to happen? It's going to tell you it's a symbol. And so there you have it. In JavaScript, we have 7 primitive types: undefined, string, number, boolean, object, which really should be null, but that's just how JavaScript interprets it. Some people think it's a bug, so keep that in mind. And then we have the object literal, which will obviously return object, and ECMAScript 6 added a 7th primitive called symbol. And just remember that each one of these objects also has a value of function. In this case, you will see that we return the actual value of the string. And in case of a number, if I output it here, you'll see the number will actually appear in the console as well. So sometimes when you're not sure what the value is of a particular object, there will be times when you will have to use the value of function to determine that. And that's it, guys. There's really not much else you can say about primitives. Just use the typeof function and value of, and make sure you understand dynamic typing, which is basically pretty easy. You can change a type of a variable to any type of an object without redefining them again, and that's dynamic typing. Okay, guys, thanks for watching my tutorial, and I'll see you in my next one.